My name is TamaraHolt, and my project is on the Arizona National Scenic Trail, a least cost corridor analysis for trail reroutes. The Arizona National Scenic Trail is an 800-mile non-motorized path the length of Arizona from the border of Mexico to Utah. The trail travels through 4 very distinct scenic regions. The first and second image are within the Sky Island mountain range, displaying the drastic contrast of the Huachuca Mountains, which are over 9,000 feet in elevation, and the low desert of Rincon Valley. The third and fourth image are within the Sonoran Uplands, showing the very rugged terrain of the Superstition Mountains and Saddle Mountain. The center area of the map, highlighted in pink, is Coconino National Forest. This is the location of the project and will be discussed later in the presentation. The fourth scenic region is the plateaus and canyons, which are the top 2 images of the Grand Canyon. This is the south and this is the north rim. The Arizona Trail was officially completed in 2011 and is federally protected as a National Scenic Trail. As a National Scenic Trail, it is required to have a comprehensive plan which assesses the environmental impacts and safety of the trail. In 2023, the Arizona Trail Association, which is a nonprofit organization responsible for maintaining the trail, received a grant from the U.S. Forest Service to implement 12 trail reroutes within 4 of the U.S. national forests. The objective of this study was to conduct a least cost path analysis to determine the optimal path and a least cost corridor for trail reroutes at 3 sites along the Arizona National Scenic Trail. A list of criteria that follows the comprehensive plan was provided by the Arizona Trail Association. The first step was to gather the data. I needed to locate what variables were present at each site and why the trail was being rerouted. The second step was to create a workflow on the available data, and the final step was to create a model in ArcGIS Pro Model Builder so the Arizona Trail Association could use the application for future trail reroutes. The project was divided into 3 study areas within Coconino National Forest. This is the 3rd scenic region, Volcanic Field and Ponderosa Pine Plateau. It starts from the Mogollon Rim and travels north of the San Francisco Peaks. The first study area is Anderson Mesa in the center of the map. The second study area is East Clear Creek, about 50 miles southeast of Anderson Mesa, and is the smallest study area. And the third study area is Maverick. It is the largest study area, slightly northwest of the San Francisco Peaks. These 2 sites were used as the control study areas because extensive fieldwork and analysis had been completed by the Arizona Trail Association. Also, they provided GPX data for their proposed trail reroutes, which I compared to the model for accuracy. The data used for all study areas were from U.S. Geographical Society, which provided 10-meter DEM data, and the Topo Map collection, which contains contours and hydroflow lines, water bodies, wells, mountains, and roads. The Arizona Trail Association also provided AZT passage data and water source data. And the Arizona Bureau of Land Management provided Forest Service land data. The first study area is Passage 30 along Anderson Mesa, located in Coconino National Forest. This red line here is an old forest road. It's also the original Arizona Trail. And the reroute goal was to remove it from the old forest road. And this area here becomes muddy during seasons of heavy rain and snowmelt. This is the first control study area because GPX data was provided for the 2 proposed trail reroutes here in brown along Lake Mary. FEMA flood data was provided for this site analysis. The second study area is Passage 27 near East Clear Creek within the Coconino National Forest. The reroute goal for this site is to replace a steep, eroded, and poorly designed trail with a more sustainable grade. This area has some field work and analysis completed. However, it does not have field GPX data for a reroute yet. The variable at this site is the steep slope terrain here crossing East Clear Creek. The third study area is Maverick, Passage 34, northwest of the San Francisco Peaks and Coconino National Forest. It travels along a dirt road from Kelly Tank up to Cedar Ranch. Approximately 75% of the original trail is on an old forest road. This study area is almost complete with extensive field work here you can see in brown and analysis, and has GPX data for the field reroute. The variable at this site are the steep slopes from the surrounding mountains. In Model Builder, I created 3 models for each study area using Model Builder ArcGIS Pro version 3.2. I'll explain the process in the next slide using Anderson Mesa as an example. This is the Anderson Mesa methodology. 10-meter DEM was used to create the slope percent rise and then reclassified. The DEM or surface raster, the reclassified slope raster or cost raster, and the flood area or barrier was entered into the distance accumulation tool. The distance accumulation and aspect raster was created going northbound and southbound. All 4 rasters were used for the least cost corridor tool. An optimal path was generated going northbound from the southern terminus to the northern terminus, and southbound from the northern terminus to the southern terminus. This slide shows a comparison of the results between the 1-meter DEM and the 10-meter DEM traveling northbound with the optimal path in blue and the original Arizona Trail in red. The least cost corridor results shown in yellow has a 0.33% increase in suitable area for the 1-meter DEM, and the trail increases in length by 0.04 miles or 212 feet. This is the only site of the 3 site study areas that includes FEMA flood data. So this low percentage for the least cost corridor may be due to the flood barrier. It eliminated over 26% or 10,000 acres of the available study area in the distance accumulation roster, which was shown in the last slide here. This white area is no data. This slide shows the distance comparison between the Arizona Trail Association proposed field reroutes, these brown dots, and the 1-meter and 10-meter DEM optimal path generated by the model. The near tool was used to determine which optimal path was closest to the reroutes selected by ATA, and the distance was calculated. The mean was 41 feet, median was 26 feet, with a standard deviation of 45 feet. Of the 1,370 field points, 700 were within 51%, or 26.3 feet of the optimal path generated by the model. The 1-meter DEM path was closest to 898 field points, or 66%, and the 10-meter DEM was closest to 472 field points, 34%. For study area 2, the map results include a least cost corridor area, which is approximately 50% of the study area. This large least cost corridor area size gives ATA more options when choosing the ideal trail location. Here is the elevation profile comparison between the original Arizona Trail and the optimal path generated by the model. The greatest difference between the route was how the model created a path across East Clear Creek. It shows that there is approximately 11 feet difference between the elevation gain and loss for the 2 paths, and a difference of 2% for the maximum percent slope. The elevation profile shows a steep slope of concern. This section of the trail crossing the East Clear Creek will most likely need to incorporate switchbacks since the percent slope rise exceeds U.S. Forest Service criteria of 8%. For study area 3 Maverick, The mean difference between the optimal path and the trail reroute was 6,347 feet. The median was 6,141 feet, and a standard deviation of 3,261 feet. The maximum distance between the two was 12,700 feet, or 0.62 miles. This chart shows the distance distribution from the field data points to the optimal path. You can see that this model is determining the least cost path from point A to point B here in this the blue line. However, the ATA trail reroute chose a longer path on top of the mesa to provide a better view shed for the trail. South of the southern terminus is the San Francisco Peaks, which are above 12,000 feet, and north is the Grand Canyon. This trail reroute provides an incredible view where the optimal trail has a limited view because it is below the mesa. I selected a midpoint in the least cost analysis to see how the model would perform. I chose the furthest west field data point. These are the results for the least cost corridor with a midpoint, which is here. The optimal path follows the contour of the terrain, similar to the GPX field data points. The suitable corridor area dropped by 12% to 10%, or approximately 9,000 acres. The mean distance decreased over 1,600 feet to 4,694 feet, and the median distance decreased 1,700 feet to 4,420 feet. The standard deviation was 2,647 feet. The optimal path length increased by 0.7 miles. An elevation profile comparison shows the midpoint path and the field data were very similar, and the optimal south path and the Arizona Trail were alike. The most significant difference between the original Arizona Trail and the field data points. The biggest reason for the slope change is the Arizona Trail is approximately 75% on an old forest road. Based on my analysis of the two elevation profiles, the midpoint path is the more favorable path. In conclusion, Anderson Mesa has the lowest least cost corridor area as compared to the other study areas. This means there is not that much room for deviation or options for the trail reroute. This is because it is the only area which includes flood zone data. The optimal path for the optimal path for Anderson Mesa was very similar to the field data. However, the optimal path was very different from Maverick, which may be due to the large size of the study area. Future suggestions for the model are for larger study areas like Maverick, it would be helpful to break down the trail into smaller sections, running it through the model. Another suggestion would be to run a viewshed analysis first to acquire the best scenic points for the trail. If the best scenic locations are data points, I would use the least cost corridor method. However, the viewshed analysis can create regions. Therefore, I would use the optimal corridor connection to find the optimal path. And here are my references. And that's the end of the presentation.